Okay, so let's look at creating an equation of a wave from a graph. So they've given us this graph, and I already started to write a couple of things in, but let's kind of talk out loud about what we are doing here. So from the looks of this graph, it doesn't look to be really hitting whole numbers as we go through it. This would be 500, and it's not quite at 600, so we're just going to go on the assumption that's halfway between. So it looks like the y-intercept of this is going to be at 550. The next is what's really important for these is in order to create these equations is we really want to know where are the peaks and the troughs, so the highest, the max, and the min values, because then we can start to find the equation of the axis and a whole bunch of other things from there. So this peak, again, if this is 900, this looks like the y value of it is going to be around 850. And the x value, well, in between 0 and 4 would be the value of 2. So that would probably be 2. And this looks like it'd be 1 because that's the halfway. So we're looking like halfway between 1 and 2, which means this is 1.5. So one of the peaks is 1.5 and 850. Let's talk about the trough, or the minimum value. Same idea. Again, this looks like it's halfway between, so we're going to say it's 250 as a y value. And for an x value, again, if this is 4 and this is 5, that looks like it's going to be 4.5. So from the peak to the trough, those will be helpful because we can start to find the equation of the axis. And the equation of the axis is going to give us a lot of information. Do you guys know how to find the equation of the axis?
Find the amplitude?
It's kind of, it's kind of like finding the amplitude equation.
Plus min divided by 2.
Yeah, so we have our max plus.
It's plus.
Yeah, divided by 2. If we did minus, do you know what that would find?
The amplitude?
That will find the amplitude. And we're going to need to do that anyways. So the equation of the axis, max plus min divided by 2. So we're looking at 850 plus 250 divided by 2. So this is looking to be 1,100 divided by 2. So I think it's at 550, which is exactly where this started. So that hopefully makes things a little easier. So it looks like our equation of the axis is going to be at 550. So that's going to be important because the equation of the axis, and I know this picture is kind of on a slant here, but the equation of the axis is going to tell us, depending on which, actually it doesn't really matter from which of these, but the equation of the axis is going to tell us really our c value, how far our c value is moved. Because if you remember from sine and cos, the equation of the axis is always right along the x-axis. In other words, it's when y is equal to 0. Okay, 0 does that. So if our equation of the axis is normally at 0, and then our new equation of the axis is at 550, that means our c value has shifted up 550 units. Okay, so the equation of the axis tells us what our c values are. So because for sine and cos, they both have the same equation of the axis, that means the c value for both of them is going to be 550 positive. Okay, so that helps us figure out what our vertical shift is. Along with that, like you said, was the amplitude, right? And I guess I should have done this one in orange. Oops, that's not quite orange. I don't think that would have been orange. I think I did amplitude in red. So let's go back to red now. Our amplitude, so we'll just call it our a value, is very similar idea, but it's max minus the min divided by 2. Okay, so this time we're taking 850 and subtracting 250 and dividing that by 2. So that's going to give us 600 divided by 2, which is 300. So it looks like our a value, okay, and again, the amplitude for the parent function of sine and cos will be the exact same. So all our vertical stuff should be relatively the same. The a value should be 300 for both of these, so our a is going to be 300. Oops.
Oh, just a question. Like, I'm not sure if that's the right way to do it, but that's kind of what I did in the homework. I took the, to find the vertical shift, because that was like the second question. I already had the amplitude.
Yeah.
I did, so I did the min, which was 250, plus 300.
Yeah.
And I got 550. Was that just a coincidence? Or
no, that's what you would end up doing. So you took the minimum value of the original one?
Yeah, the 250.
Of the 250, and then you did what to it?
I added 300. I added the amplitude.
You added 300 the amplitude.
And I got 550. For the vertical shift. That's what I was, like, for C.
Right. So you were at 250, and because you already knew the amplitude would take us to the middle. You added 300 more to that. 300 plus 250 gives us our 550. Yeah, it doesn't matter which order you solve those two in. One will help you kind of solve the other. Okay, so we've figured out that much information. Now, on top of that, we need to find out what our phase shift is, which is a horizontal shift, and our amplitude, our horizontal shift. So we need to find the period of this function, right? And in order to find a period, it's when the pattern starts to repeat. So we already have like a peak or a trough, so a max or a min. We just need to find another max or a min, and the difference between those two will actually tell you what the period of that function is going to be. Okay, so let's go along and kind of just find the next max. The next max, again, doesn't look like it's quite at 6. This would be 6, this would be 7. This looks like it's at 7.5 and 850 again. Okay. And then if we did the same with the bottom, this kind of looks like it's at 8.5 and 250 again. So the difference between the max and the min should be the exact same. And let's kind of do this in blue just so we can kind of figure this out. The difference from 1.5 to 7 is an addition of 6. And 4.5, oh, did I say that right? Oh, this is not 8, that's why. This would be 10.5. Thank goodness we figured that out. 4.5 to 10.5 would be an addition of 6. So the period in this one is actually only 6 units. Okay, so this is very, very different from, depending if we're working in degrees or radians, we're going to say we're working in degrees. Is that what you guys work in? Mm-hmm. Yeah, okay, so we're going to say we're working in degrees. Our K value. Think of it, there's a little formula you could say that the new period is equal to the old period divided by your K value. Okay, so our new period is 6. And the old period, do you know what the period in degrees is for sine and cos?
360.
It's 360. It's always 360. Okay, so in order to get this new period, we need to isolate for this K value. Okay, we would bring K over and multiply, then divide by 6. So you'd end up with K is equal to 360 divided by 6. Okay, and then your K value here would be 60 units, and I think that's what you had said there. Yeah. So your K value, the period of the new function, or this K value, would be equal to 60. Okay. And now we're looking at the last thing, and this is the one that's going to be different depending on which function we're working with. Okay. So let's try to think back to, and what we need to do actually is we need to take the parent function and input this new period to figure out what our D value is going to be here. Okay, so let's kind of draw a quick rough sketch of what sine and cos would be, okay, with that new period. So if you remember before, we start at 0, we have a high point of 1, a low point of -1, right? And it's normally at 90, 180, 270, there we go. 360, and we're just going to assume they come straight down, okay, so I don't have to write those numbers again. If it's at sine, we're starting at the origin, and we're peaking at 90, it's not quite a wave, coming back at 180, going down, and coming back. So this would be our normal period of the parent function. With the new period that is at, that's all right. At the new period that's at 60, K value being 60, this means this is going to occur many, many more times throughout this. Okay, in fact, it's going to occur 60 more times. It'd be almost very, very difficult to draw. So we can kind of use something called a mapping notation. What mapping notation is, there's two formulas here. As long as you have the old coordinates and the new coordinates and one of the movements, you can kind of figure out the other stuff. So this would find your new y value. You need to have your old y value and either the c or the a. But we already have our c and our a, so we don't really need to do anything with the y's. We've just discovered what k is, so we need a new y value and a new x value and an old x value to isolate for d. So we're going to use this formula here to isolate for what our d value would be. So with that being said, with our coordinates, so we can really take one of the old max. So let's work with a max value. Okay, a max value with a sine x. One of the coordinates would be 90 degrees and 1. Okay, so that would be your x and your y. A max value for your cos x would actually be 0 and 1. Okay, so this is where the d will be different depending if we're using sine or cos to solve these. So that would be, consider that like the old values because they're from the parent function. They're from the original one. Our new function, let's find our max value. One of the max values is 1.5 and 850. So with our new one, so x new, we have 1.5 and 850. And this is going to be the x new We don't need the y new, but that's going to be the x new for both of these when we go in the equation. So we're going to use this for
so
one.
those are always the x old?
Yeah, those are always the x old. Think about them from the parent function. We're always doing transformations from our parent function, right? And if it was cos, these are the values we'll use, okay? So we'll solve for sine first. So our new x value is 1.5. So we plug that in for x subscript n, so the x new, is equal to the x old, which was at 90. Our k value we just figured out, which was 60, and we would need to have our k value in order to do this. And what this will do is allow us to isolate for d in this question, okay? So when we bring things over, we got 1.5, subtract 90 over 60, what is that? 1 1/3, I think. 3 over 2. Subtract 3 over 2 is equal to your d value. This will be doubled, will be 3 over 2 again. Over 1 times 2, yeah. This is 3 over 2
0
minus...
to 0.
Yeah, 0 over 2, perfect. So the d value here is going to be 0, assuming we're using sine. Okay, so there's been no phase shift according to this. We'll use that same notation, but with cos. Okay, our new x value is still 1.5, but our old x value in that one was 0. Okay, so we have 0 divided by 60 plus d. 0 divided 60 is going to be 0, so we're going to end up with 1.5 is equal to d. So depending whether it was cos or sine, whichever they want to solve in, our d value is going to be very, very different. Let's highlight it here. So our d value for cos is 1.5, and our d value for sine is 0. So when we go to create the equations, okay, we said our f at x was equal to the amplitude we found to be 300, was it?
Mm-hmm.
Okay, so that's going to be the same for both. We'll call g at x the other function. Okay, for sine and for cos. The k value for both was 60. Then we have x subtract whatever the value is, x subtract. We'll write that one in last because it's going to be different for both of them. And the c value we said was 550, I believe.
Yeah.
Yeah, so it's 550. 550. So if it's sine, the d value was 0. Okay. And if whether it's plus or minus 0 doesn't make a difference. Here, the d value in the cos was 1.5. So when we write it in, it actually looks like subtract 1.5, even though it's been shifted 1.5 units to the right. Okay. So really, the hardest one to find in all of this is your horizontal shifts when going through it. The mapping notation makes it the easiest way to find it because you have a formula that you can kind of just work out.